And sometimes we're going to have rational expressions which do not require factoring. You don't see any adding or subtracting going on. And here we're going to take a little bit different of a route to simplify this. We've got a coefficient of 2 and 6, and we have both x and y raised to different powers. And for the coefficients, we're just going to reduce as we would any fraction. 2 6 reduces to 1/3. But for our variables, think of it as 2x's on top and 5x's on bottom. If I were to write that out and cancel where I could, I would have 3 extra x's on the bottom. Just simply subtracting your exponents when I divide powers. Similarly with y, I've got 3 y's on top. I've only got 1 on the bottom. Think of that as a 1. That would leave an extra 2 on top. And since we don't like to write 1's unless we absolutely have to, the perfect answer would be y squared divided by 3x to the third. So again, reducing the radicals, or excuse me, reducing the coefficients as if they were a fraction and subtracting exponents when you divide powers. Applying that to a multiplication situation, remember when I multiply fractions, I'm just going to go straight across. We have a choice here. You could simplify some stuff, then multiply, or multiply first, then simplify, which is what I tend to like and what I'm going to do here. So what we have here is 8 times 10, just multiplying the coefficients, which that's 80. With our exponents, we're just going to add, because when you multiply powers, you add exponents. There's 1x here, there's 1x there, for a total of 2x's. And we just have the 2 y's on the left. Then the same thing on the bottom. 5 times 4 is 20. 3 plus 6, that's 9 x's. And we'll have 6 y's here. Okay, so multiply coefficients, add exponents. And now here we're in the same situation as we were right here. You're going to reduce this fraction. 80 over 20 is 4. Think of it as 4 over 1. I'm going to hold off on writing that 1 until I know I need it. So it's 4 on top would be a 1 on the bottom. But if you look here, we're going to have 7 x's on the bottom because there's an extra 7 down here. 9 minus 2 is 7. And we have 4 extra y's on the bottom. So the product is 4 over x to the 7th, y to the 4th. Now one more thing here. I didn't mention excluded values. It seems to be less of a concern when you're not factoring, but it would not be wrong in either case to mention that neither x nor y could equal 0, because if they did, it would make both of these problems undefined. And now we want to divide rational expressions. When you divide fractions going back here without the calculator, remember the old saying, keep, change, flip. It's what you were taught years ago, to where we keep 2/3 and we change it, or keep it 2/3. The change is going to be with operation. It changes to multiplication. And we flip the second fraction. Let's turn that upside down. It's called the reciprocal. And by definition, reciprocals are two numbers that multiply to give you 1. But for fraction, you just simply flip it. And now we've very quickly changed a division problem into a multiplication problem. And we can just proceed as before. Multiply straight across. 14 over 15. So applying that to rational expressions, again, we've got the big ugly fractions, so to speak, and we can't cancel anything as they are because of the concept of glue that we talked about before. This x squared and this 1 is attached. You can't cross out anything at all unless you cross it all out. Nothing matches perfectly on top and bottom. So we're going to go about factoring, and again, if you're a little weak on factoring, you might want to remediate yourself a bit. But x squared minus 1, It's going to be the difference of two squares, x plus 1, x minus 1. X plus 3 is not going to factor. The factors of 3 that add to give you -4, those are going to be -3 and -1. -3 times -1 is 3. -3 plus -1 is -4. And the factors of 9 that add to give you 6, using a similar method as x plus 3 and x plus 3. Okay, so we've factored right away. Now you have to be careful here. This is a division problem, so we do want to flip. And you may like it better actually to flip first. Here I factored first. I would advise against trying to factor and flip at the same time. That would be a little dangerous. Would open yourself up to make more mistakes. Generally, you don't want to multitask unless you have to, because multitasking is just a halfway job at two different things. So I'm going to do one thing at a time. I factored, now I'm going to flip. Do not think cancel out until you have flipped here. And it's only with division problems that you flip. Okay, so I'm going to flip this upside down. Remember, keep, change, flip. So I do not flip the first one, only the second one. Okay, that's x minus 3 here. And now we'll look to try to cancel things. It doesn't matter what fraction you're in as long as you have one on top, one on bottom. So I see this x minus 1. It'll cancel. And I see this x plus 3 that'll cancel. And it doesn't matter which one you cancel it with. So your quotient here is going to be, if we have room, x plus 1, and one of those x plus 3's is still on top. And along the bottom we still have this x minus 3. So that would be my quotient. Now we do like to mention our excluded values, and anything that was ever a denominator cannot be 0. That is before you flip and after you flip. If we look back, what would be our excluded values here? Well, looking at the original problem a lot of times doesn't help, but when you factor, you can see what makes zeros along the bottom. And here's the exact same factor all the way across. So we can see, and we can easily compute in our minds, if we set x plus 3 equals 0, then x there would equal -3. So -3 is going to be an excluded value, because if I allowed x to be -3, it would render this denominator 0 and this denominator 0 as far as that goes. And that would be an undefined expression. But after you flipped it, we pick up two more excluded values. Still the same one over here. We've already mentioned -3. But what would you get if you set x minus 3 equals 0? Well, you'd get +3. So x cannot equal +3, and x also cannot equal +1. Because if x were either 3 or 1, it would make this denominator be 0, and you can never have a 0 denominator. And this one's a little harder. The factoring technique has a number in the front, and that's going to require you to use a little bit more to factor it. But if you were to factor this, which again, if you have trouble with it, just leave it in the comments. It's going to be 3x plus 1 and x plus 2. If you were to multiply those back together, you'll find that to be 3x squared plus 7x plus 2. Bottom here is just a monomial. It's not going to factor, nor will the upper right hand corner. Now right here though, there is a GCF. Even though this is x to the first, you can take a 4 out of here. If I divide 8 and 12 by 4, I get 2 and 3 respectively. So that will factor. Always look for a GCF when you factor. So I've factored. Now I'm going to flip. We flip only the second fraction, not the first fraction. And if you wanted to flip first, then factor, that's fine too. Okay, so what's going to cancel? The 3x plus 1s are going to cancel. And these 4s also cancel here. Remember, this 4 and this x do stand alone as separate factors. There's no plus or minus which binds them together, so to speak. They stand alone. So it is okay to cancel this 4 out and leave the x because they don't have the plus or minus between them. So it cancels with that. And I'm left with x plus 2 over 2x minus 3. And there is still an x left on the bottom. Now this x does not cancel either one. Remember that I can't cancel this x out and leave the 2 or pull this x away from here. So this is my quotient. As far as my excluded values, looking back to where I first factored it, what value of x would make a denominator 0? Well, 0 here. If I set 4x equals 0, then you're going to get x equals 0. So x cannot be 0 because if it were set equal to 0, then this denominator would be 0. You can't have that. And right here, it's not quite as obvious, but if I set 2x minus 3 equals 0, I would add 3 and divide by 2, and that's going to give you 3 halves. So x cannot be 3 halves. After you flip it, you have this denominator, and negative 1/3 would be what you get if you set 3x plus 1 equal to 0.